Alright guys, so today we will be discussing angular momentum and identifying the specific impacts it has on rotational motion. We will be conducting two demonstrations that deal with the law of conservation of angular momentum. This chair sucks. The main difference between our first experiment and our second experiment was that in our first experiment, instead of spinning the wheel to start off on the floor, we spun it while Mitch was standing in the chair. Now, what this does is it creates an angular momentum, which we know is perpendicular to the direction of motion. So, Mitch started out holding it vertical, and then he turned it to the left, causing the wheel to spin in a clockwise motion like that. Now, a good way to remember where the angular momentum is going is by using the thumb rule. So what you do is take your right hand, and whichever way your thumb is pointing when you curl your fingers around is the direction of angular momentum. So if we were to turn it clockwise, my fingers would be going this way, my thumb would be facing down. So angular momentum in this case is going down. When Mitch got up on the chair, the wheel was spinning this way, which caused the chair to rotate in the opposite direction, going counterclockwise. If we take angular momentum as L, Mitch started out with a negative L because the wheel was spinning in the clockwise direction, which caused the angular momentum to go down. Now when he got up on the chair, he has a plus L to equal 0, which satisfies the law of conservation of motion, or of angular momentum, sorry.
Okay, so when I was on the floor first, and I spun the wheel and flipped it so that it was rotating clockwise while still on the floor, the angular momentum was set to be negative L. And then when I got in the chair and flipped it all the way over, so it was rotating counterclockwise, that made the angular momentum of the wheel change to positive L. Therefore, since L is equal to L prime, and angular momentum is always conserved, if the wheel goes from negative L to L, then the chair and I have to move the angular momentum of negative 2L. So therefore, L plus negative 2L is equal to negative L, so the total angular momentum of the system stays the same. And since the total angular momentum is conserved, and I had to move the negative 2L this time, that's why you saw me go around further than when I just flipped it half the direction instead of the full turnover.